Alright, everyone, let's talk about something very real in microservices. And today's question is a change in one service breaks other services, and how do we prevent that? This problem happens in almost every team who has worked on microservices. So, first, understand the big difference. So, in a monolith, life is easy. You change a method, you update all the places where it is used, and you run test cases, and done. But in microservices, it does not work like that. The moment another service start using your API, it is no longer just your code. It becomes a contract, and contracts are not things you casually change. So many teams think like this. It is our service, we own it, we can change it. Yes, you own it, but other teams are dependent on it. So the moment someone builds their code based on your API, they make assumption. They assume this field will always be there, this format will not change, and this validation rule will stay the same. This behavior will not suddenly act differently. So when you break those assumptions, production breaks. And here is the interesting part. From your side, the change may look small, removing a field or renaming a field or making validation stricter, changing a response format, and changing behavior silently. But for other service, it can completely crash their system. So how can we prevent this? Let's break this step by step. So the first step is treat APIs like a contract. The most important mindset shift is this. Once your API is published, assume someone depends on it always. And I don't care if it is REST, gRPC, events, or message queue. It is a cross service boundary. It is a contract. So before changing anything, ask who will this affect. And if you don't know the answer, that is already a red flag. Because teams that treat APIs like internal code move fast in the beginning, and teams that treat APIs like contracts, they only build the stable systems for years. Now we'll talk about the backward compatibility. So these are the basically five key strategies to we can use to prevent breaking the changes. So first one is backward compatibility here. So this is like this is your strongest protection. Backward compatibility simply means old clients should still work after you release a change. And if you follow this rule strictly, most problems disappear. Here is a simple rule basically which I usually follow. So add any new field, make fields optional, and add new endpoints instead of changing old ones. And these are the dangerous changes which can break the system. When you are removing the fields, you are renaming the fields, and change means of field, and make always optional fields required. So I always tell teams like add, but don't break. And if you live by that rule, you avoid most of the production issues. So this is the rule, like add and don't break. Next one is API versioning. So versioning is about safety, not like the beauty. You can version like v1, v2 in URL, version in headers, or in the different media type. The exact method is not the main point. The main point is this: versioning allows old customer to stay stable while new consumers move to the new version slowly. But here is something important. Versioning should not be your first move, because you are now maintaining two APIs, twice the testing, twice the documentation, and twice the maintenance. So first try backward compatible changes, only version when you truly cannot avoid breaking the behavior. So think of versioning as a safety switch, not your default solution. And the third step, that is a contract testing. So this is powerful, because contract testing helps you catch breaking changes before they reach the production. So instead of finding out after a user's complain, your build fails early. The idea is simple. Consumers define what they expect, and providers must satisfy that expectations. If a provider change breaks that expectation, the build will fail. And let me explain that difference very clearly. So integration testing always asks like, does this work today? While the contract testing asks, if I will change something tomorrow, will it break someone's code or someone's system? So this is a big difference, and it will basically protect uh, your stable systems. Now moving on to next, that is events and schema changes. So in event-driven systems, and this becomes even more important because not everyone upgrades at the same time. Some services may read your events days or even months later. So events must always be backward compatible. And best practices for this is never remove fields, and add new fields with the default values, and create new events type instead of modifying or changing the older ones. So think of events like history. Once you publish them, they represent something that already happened, and you cannot rewrite history, right, without creating confusion. So that was for the schema evolution for events. Next one is clear deprecation strategy. So breaking changes should never surprise anyone. A good removal process will always should always include uh, like inform the teams early, clear documentation, and track who is still using the older versions, and give a clear deadline for the removal of any changes or anything. So give always people time to migrate. Deprecation is not just technical, it is about trust. If teams trust you, collaboration is smooth. And if you surprise them, everything becomes very painful. Now let's talk about what are the common follow-up questions that can be asked for this question. So first one is, why not just update all the services at the same time? So in theory that sounds perfect, but in reality it does not scale. Different teams release at different times. Some services may be external, some may have long approval cycles. If everyone has to release together, you lose independence. And independence is the whole point of the microservices. Next question can be like, is versioning always a good idea? So no, because it will increase maintenance work. Always try backward compatible changes first. Version only when there is no other choice. Next question can be contract text testing versus the integration testing. So integration testing checks if things work now, while the contract testing checks if future changes will break someone or not. So integration testing protects the present, while the contract testing protects the future. And in our system or reliable system, we need both. Next question can be, what about the database schema changes? This is very important question, and use something called the expand and contract approach. So add new columns, slowly move data, update application code, and then remove old columns only after everything is stable. Never change database and code blindly at the same time. that is a classic way to cause system outages. Next question can be who owns backward compatibility? So the provider owns it. If you publish an API, you are responsible for keeping it stable. Consumer trust you, and that trust is the foundation of the distributed systems. And the final takeaway from this question is systems usually do not break because they are complex. They break because contracts are ignored, and changes are not communicated, and communication is weak. So strong microservices are not built only with good code. They are built with discipline. They are built with respect for contracts. And if you remember only one thing from today, remember this. In microservices, stability is not accidental. It is designed and um, thought earlier and before advance only, while making a reliable and stable system. So that was all for these questions. If you find it useful, please provide your comment so I can keep on creating such type of more videos in future. Thanks for watching.